Okay, so we are going to be talking about an introduction to Julia language today. So this is a very basic introduction, and if you don't know like programming at all, it should be good for you. But I do assume that you have at least used some like either MATLAB, Python, or anything once before. So if not, if you have questions, feel free to interrupt me or ask me in the chat. So let's get started. Julia is a relatively new programming language. It was started in like 2009 at MIT, but it has gained a lot of traction, especially in the academic community, because it is designed for researchers and scientists. And the main selling point of Julia is that it is a reasonable compromise between slow and interpreted languages like Python and fast and compiled languages like C. I say it is a compromise because I've seen a lot of online fighting between people who are like who claim that Julia is not exactly like C, which it is not. But I think it does solve the two language problem very well. Like you do not need to create a prototype in MATLAB, then rewrite the program completely in C and go back to MATLAB for visualization or plotting. You can do all of that in Julia, including prototyping, as well as creating like a product for shipping. So yeah, the main focus is numerical computations, performance, as well as ease of writing. And I have used Julia for a couple of years, and I think it is relatively intuitive for most people, even if they don't have any programming experience. And it has a very good online documentation and package ecosystem. So when I started using Julia, a lot of things, like a lot of features were not present, but just asking questions, I could get a lot of help with very obscure, detailed mathematical problems, which are not quickly available. And last point is, I think it's time to move on from Fortran. And this is a joke, like don't take it too seriously, but I think, yeah, we should focus a little more on Julia. So you can download Julia straight away from their website. I think it's pretty straightforward, and they ship binaries, so you can just click and download. It works fine. I recommend that for first-time users. If you want to use it on Oscar, we have a Julia module. You can load that and use it as it is. Some features of Julia is it is fast. It was designed to be fast. And what it does is that I would say it is like halfway between a compiled and an interpreted language. So interpreted language is something where uh, the computer reads your instructions line by line and evaluates it line by line. Compile is you give the instructions to the computer, it takes them all at once, converts it to the machine code, and then just runs the code. So Julia uses a native compiler called LLVM. Python and others also use in specific instances, but they were not designed to do this. So with Julia, you can write like code as fast as a compiled C language without going through the intricacies of C or C++. Julia is dynamic, which means that the interpreter and the compiler both actually are able to guess the type of the variable that you use right during runtime. You don't have to like explicitly define it. And there's a couple of things here which I'm not going because this is intro with which is very like a good selling point for Julia is that it uses multiple dispatch. And without going into too much details, you can think of this as the compiler knows very efficiently which of the multiple defined functions would be the fastest for a given set of instructions. And yeah, so Julia is open source and it has like most features of modern programming language. So you can create packages, you can even create binaries for other people and all that stuff. So I'm using Pluto Notebook here to present and talk about Julia language. If once you download Julia, I think it should already be in your path and you can open a terminal and use Julia via terminal or a development environment like VS Code or something. So Pluto is a notebook like Jupyter Notebook made natively for Julia. It has slight differences, but I just wanted to try it out. So this is it. And I would recommend if you want to start any project, even if you're doing like a basic thing in Julia, is to use environments. These days, even Python and everything, like they push for using environments and not doing everything in your native code, because then you have conflicting packages. So Julia has a very nice package management system. You can press this square bracket to enter the package management system from the Julia terminal. And you can generate, this is a typo, it should be environment name, not package name, but you can generate an environment you want. And environments are nothing but a collection of packages that you have. It is good to have different environments for different projects so that you don't mix and match. And to begin with, we will add some custom packages, one of which is plots and other is Pluto. Pluto is the notebook that I'm running the code on. And what this does is that if you look at the, it creates a folder inside your package, inside your folder basically where you're running Julia, and it will create some metadata and markup languages. What this does is it makes the environment reproducible. And if I add like 20 different packages here and I forget, and I want to give this code to you, so you don't have to remember those 20 packages, like those information is present in these two files. So I shared the GitHub link for these slides on Slack in DSCoV channel. So if you can clone that and you have Julia, if you just activate your package environment name, you should have all the packages that I'm using here. There's a couple more than plots and Pluto, but this is an intro, so we are not going to go into details into other packages. So yeah.
I installed just now, and I just typed like Julia, it went inside, but then when I like opening the bracket, it goes like ask for the packages. It's not giving me this option to generate the environment.
Oh, so when you type this square bracket, it enters into a package environment, and then you have specific commands that you can use to download packages or just keep it. So if you type generate, and so I call mine like intro_Julia, you can call like generate package 1. So it should create a folder in your directory. And within this package management, you can add specific packages. I think like to start with, you can try adding plots and Pluto. Oh, we can discuss, I guess, maybe, yeah. I'll let you go through it. So we are using the Pluto notebook, which is very similar to Jupyter notebook. Inside Julia, after activating an environment, you can add using Pluto and pluto.run to create a new notebook in your web browser. And how Pluto is different from Jupyter notebook is that it is reactive. Reactive means that if you change something in one cell, the changes are propagated through other cells. In Jupyter, what happens is that you have to run the cells line by line. So if you change something in like the 10th cell, you have to go back and rerun the 8th cell or the 12th cell to make the changes. Here, for example, if I have a variable called a equals 6 and b equals a plus 2, now if I change a to 7 here and run this, b automatically changes. So this is nice feature of Julia, like you don't have to remember the variables, but this also has its own caveats. Like you cannot have multiple definition of a in multiple cells. You can't say a equal to 7 once and a equal to 9 again. You have to either put them in a function or define them like more clearly. Yeah.
So this is something I've always wondered about Pluto is how does it handle, so if it's reactive and reevaluate stuff, how does it handle if you like, if you have some, let's say you have a big data set or some long running simulation or something like that, how does it handle something where like it might trigger a rerun on a cell that you really don't want to rerun?
So I had a similar question and I looked at the discussions in Julia. I think one example is I'll get to it a little later, but if you have a mutable struct and you change the value of mutable struct, that does not change the original value because it is encapsulated in a structure like a data type. And the recommended way to avoid these changes is to either have like everything inside a function or just be more modular. So that is what I found, but I think this is still kind of an open discussion. So people are talking about it like in 2023. So yeah. Okay, so the first program everyone uses is Hello World, nothing like fancy, but in Julia you use the function println, which is just print line, and you can have a string or anything inside that, and it will give you an output. In Pluto, there are two types of output. The one we saw before is the cell output, where you have variable assignments. There is also a terminal output or something which you can which it like echoes or prints inside the terminal, which is basically how Julia is interacting in the backend via Pluto. So don't worry too much about it, but just look at it like the output is black and green rather than just a white. But if you like assign this to a variable and store it in a variable, then you can have those variable output in each cell as well. So data types. If you are familiar with like any programming language, you know most programming languages have multiple data types. And just like a brief overview, this is a little theoretical, but I think this is still like intro level. So you can have like a static data type system or a dynamic data type system. Static is typical for compiled languages, so think something like C or C++, where you create an executable out of a set of instructions and run them like once. And dynamic is typical for interpreted languages like Python or even MATLAB, where you can run statements line by line and have like it output for each statement. So the difference is that in a static type system, every expression must have a type which can be like computable by the compiler beforehand. So once you pass the set of instructions to the compiler, it already knows what every variable is, and it allocates memory and operations in such a way. Whereas for dynamic type system, it is more flexible, like you don't need to know anything beforehand. When you're actually running the computations, the compiler is smart enough to understand whether something is an integer or not. It comes with its disadvantages, like dynamic is usually very slow. And if you have some huge computations, or if you want to create a distributed system, you want to go with static compile types. So Julia is very interesting. Like Julia has like specifically tried to solve this kind of problem. So it has a dynamic type system, which is very standard, which means that the compiler decides the data types at runtime. But Julia's type system is very robust in the sense that the compiler is very smart about choosing from multiple types when like evaluating a function or something. We'll go through some of these examples, but just a brief overview. The types of like variables here, you can have like primitive types, which is again common for most languages. Think like numerical types like integer, float, big float, complex, etc. Float here is, of course, these days in like Python, Julia, and newer languages, you say it is float, but it is actually called double. So it is twice the size of float, but this is just an extra tidbit to remember. Then you can have abstract types in Julia. This is also very interesting. Abstract types means that, so in programming language, you have like a thing called abstract and concrete. I think in natural languages as well, you have that. Like if I say, for example, a cup, I have a cup. So cup in abstract doesn't mean anything, which means that if you try to like put forward a definition for a cup, you will always find a counter definition which doesn't fit it. But if I say I want this cup, this is concrete. This is exactly like referring to a physical object that I want. So similarly in programming languages, if you have abstract types, it is not associated with any object or a variable, but it is very good because with abstract type, you can still like create relations between operations, and maybe like a couple of other things. But once you have like a specific object, like you have an integer, then and you like that integer belongs to a type, that would be a concrete specific type. So abstract type examples would be in Julia would be like any, which means anything, real numbers, integer, etc. And you can see that integer would be a subset of real number, float would also be a subset of real number, and so on and so forth. You also have composite types, which is more fancy, and you can have multiple instructions and complicated types. Like you can define your own data types if you're doing like a numerical simulation and you have a specific set of parameters that you want to use again and again. So you can say, I want these two things to be integer, these two things to be array or whatever. In Julia, Julia is predominantly a functional programming language, which means that you don't have classes and objects. So again, I'm not going to go too much into details about classes and objects, but in pure object-oriented languages like Ruby or Smalltalk, everything is an object, which means that everything is inherited from a base or like a higher class, and whether they are like composite or not. In C, C++, you can have integers standalone, and objects which are inherited from some class. For example, if you have like banking details, like an object of a banking class which like collects your ID, password, whatever. In Julia, all values are objects. They are inherited from like a base super type, but these functions like these objects are not the specific instances of objects are not bundled together with their super type. And this is important in Julia because Julia, again, like the uniqueness of Julia is that it allows the compiler to choose which type and which object you have associated during runtime. You don't need to do this during compile time, and it is still like fast. So I'll talk a little bit more, but I'm not going to talk about like object-oriented programming in general. Just remember that in Julia, everything comes from a super type, and they are objects, but you don't have like associations of objects and classes like you do in C++ or Ruby. Abstract types, as I said, it can be anything. This is a syntax to denote like if you want to create a custom abstract type as a subset of a super type. So you can do abstract type like abstract float, which is a subset of real. Integer can be a subset of real, and so on. Now, why types are important? I'm using another package called benchmark tools, which basically helps me benchmark time for like a section of code very nicely. So I'm assuming you all know like loops and stuff, but what I'm doing here is that I'm creating a random integer of 1000 length array, and I'm just adding all of those values. So I create like a somewhere variable which stores the values, and going through the integer one by one, I'm adding it to sum and returning it. Now here, the X variable is an array of 1000 random integers. Sum of X is not integer, it is a float, it is 0.0. So the calculations here are basically adding an integer to a float, which is a more expensive calculation than adding an integer to an integer. So if I run this, you can see memory allocation, the number of variables allocated, and the time it takes to run. Not too bad, but this is like a small example. But if I run the same code, this time my sum is 0, and I know like everything is an integer. So here I'm only performing integer plus integer operation like 1000 times. And this is like almost twice as fast as the previous one, just because integer and integer operations are like faster than integer and float operations. So how can we use this, or like how can we utilize this knowledge in terms of types? I'm going to talk more about functions later, but I created two functions, which is again adding two values. First function is called my plus typed. And here what I'm doing is that the input that these functions take, I'm explicitly stating that they have to be integers. In the other function, I'm not stating anything. So this would be this would belong to the type any because I'm not like specifying anything. And only when I do the calculation would the type be concretized. So if I try to add like two strings, it will give me a concatenation of strings because addition of strings is different from addition of integers. But Julia is able to like determine what you want to do. So if now I try the same thing as I did before, but I use functions. So it is the exactly same thing. The sum is 0, it is integers. So every calculation is being done on integers and it is 600 nanoseconds. So like as fast as the integer calculation. Now, if I do this without the type system and I have like sum as a float, so Julia is smart enough to like, most modern programming languages are, but Julia is also like smart enough to understand that you are adding float and an integer. So the output would be float, which is more expensive than an integer. But here, if I have explicitly like typed, so I have explicitly said that X and Y input should be integer. If I try to like have a float and run this, it will give me an error. Like you cannot, because the function I have defined previously is integer, as you can see here. So this is like a very small but a good way in which you can make your code faster. If you know something, if you know the type of something explicitly beforehand, you can specify that. If you do not know, you can leave it as it is. If you do this in like C or C++, you have to specify the types always, all the time. If you do this in Python, you don't have to specify it anytime. So this is a good way to like ensure that if you want the type to be propagated as an output, you can have the option of doing that, but you can also not do that. And you can gain, like this is a small speed up, but think about this. If you're doing for like a 1 million array, 100,000 times, this will be like a significant speed up just by explicitly declaring the types. Any questions? Should look at the chat as well. Now we'll move to composite types. Composite types are just more fancy way of saying you can bundle individual primitive types together in one. And one of the most like in Julia, like one of the, I think, only examples is the use of struct. It is called a structure. This is also present in other languages like C and C++. But there you have classes and objects which are slightly different from structure. Here, what you can do is that if you create an you can create like a composite type called foo, and you can have elements where you may or may not again decide to specify, like you want bar to be of any type, so it can be anything, but you want baz to specifically be integer and qux to specifically be float. So one thing to remember is that in Julia, structures are immutable by default, which means that once you created this, you cannot change this. And there's other ways to change this. You have to add a keyword mutable struct, which comes at the cost of speed. So think when you want to do that. But let's take an example of like I create a structure foo, and this has three different objects. So I create two objects based on this structure. So you can do this by like specifying what you want the value of each of them to be. So for example, first one I create where I want bar can be anything, like I haven't specified. So this comes under the Julia type any. So I can create one object where it is a string. I can create another object where it's an integer, no problem, like you can choose. The other two, like the second one has to be an integer, third one has to be a float. Now float is a superset of integers, so if you specify integer, it's not going to throw you an error. And if you like want to look at the type of this object that you created based on the structure, it will say the type is foo. So you created this custom type, which is now denoted as the type of that object. And you can get the field names for those custom types by using the function field names. And you can access individual elements by just using the dot operator. So you can do foo1.bar, it will give you hello, foo2.bar, it will give you 83. So as I said before, you want sometimes to be able to change things later. So you can add the mutable keyword and again create like a new structure bar. I'm having like two variables. One of them is float, other one is like anything. So I create an object out of that structure. I call it just like little bar and it's hello and 1.5. So the if I do like bar.qux, it is 1.5 as I denoted here, but like doing some operations, I want to change this, so I can change this. If I change this without putting the mutable keyword, it'll give me an error. So now you see that if I look at the whole object, it has changed. It is hello and 2.5 now. This is also like going back to the reactivity question that you asked, Paul. Like if this doesn't change the output of the original 1.5 if I change the struct. So Pluto is good in that sense. Like if you have things encapsulated in an object, it is fine. Questions, concerns? Camilo, then Paul.
No, I was just curious about like, did you add properties to that struct, or it's just unmutable?
What kind, like,
Let's say that you want to add another attribute called name, bar QX name.
no, I think you cannot add an attribute after the creation of the struct, even for mutable. You can add like objects. So like the struct can be more fancy that you can have functions and stuff. So which is in practice very similar to classes. But I don't think you can add like a function after the creation of struct, even for mutable. Mutable just means that these values, like they can be changed after construction. Correct me if I'm wrong, Paul. Okay.
That's definitely my understanding. I have a question related to that though. So we say bar is mutable. That means every instance of bar is mutable.
Yes.
Is there a way to restrict that? Say, oh, in this particular example, I want this bar to be immutable.
That is a good question that I haven't thought about. Let me see. I think the Julia method, like way of doing that would be you can have multiple, like using overloading, you can have multiple objects of writing the same thing. So I think that would be the way to do in Julia. You have three definitions, but in practice, you can use any one and Julia is able to choose. But I don't know, and I assume you cannot have like one mutable and one immutable object of the same struct. Just checking if I have questions in chat. Okay. All right. Constructors for a struct. So constructors are basically functions that create new objects. This is more specific to Julia, but you can like think about this in terms of other languages as well. And these would be instances of composite types that we talked before. So we have a struct square. Here we can create like a function inside the square, and Julia provides us with a like an inbuilt function called new, which automatically creates a constructor for this object. So previously, if we didn't have this, what we were doing is that we were creating an object just based on the attributes of the struct. But here, what I'm doing is if I create SQ is equal to square of 5, 3. So this means that Julia can automatically create an object based on the function inside the struct. So you see that SQ, the object has three parameters, height, width, and area. You did not need to specify the area. It is inbuilt inside the structure of the struct square. In this case, you cannot create an object independent of the function inside the struct. So I cannot specify height, width, and area manually, which makes sense because once the height and width are determined, area is locked in. You cannot have incorrect area. So if I do square 2 is equal to square of 2, 5, and 10, even though this is correct, this will give me an error. The next data types are collections. I'm sure like you're familiar with some of these in other languages as well. So you can have array, vector, matrix, and all the same things apply. Like a vector can be a matrix, like matrix is a superset of a vector. An n-dimensional array can be a superset of a matrix, and so on and so forth. The definition is very easy. You can create 1D array just by using square brackets, and 2D array by using square brackets and semicolons. There are some very useful constructors, or like you can even call them functions. In Julia, the linear algebra library, you don't need to like install it separately, but you do need to have like a using linear algebra in the beginning. This provides some very nice, simple constructors for arrays and matrices. So you can have an array full of zeros. The interesting thing is that you can specify the type right here. So if you want 0 to be float, you can say float 0, like 5,5, it will give you a 5 by 5 matrix of 0.0. But if you say int, it will give you a 5 by 5 matrix of like exactly 0. And similarly, you can have ones. And if you use the linear algebra library, you can have an identity matrix, falses and trues, which are very similar to zeros and ones. And some other like random number, uniform sampling, random number, Gaussian sampling, etc. Julia, another thing is that array indexing starts from 1. This is a very big, like people do not like this in the Julia community, but the developers want it. And I think these days they have created like a protocol where you can define custom indexing. You do that in Fortran quite a lot, but I don't know if you can do that in like Python or other languages. But I think it is fine. Like it's not the worst thing. It works. Just going through some examples, like if I say zeros of 5, it'll give me a 0.0 like repeated 5 times. But if I want specifically them to be integer, I can just specify that. I can create an identity matrix. I can create trues and falses, which is just ones and zeros again. You can access index. So if I create a random matrix of 5,5 of random numbers between 0 and 1, I want to like access the 2 to 3rd element of the 4th row. You can do that. Yeah. So another interesting thing in Julia is like it's called the vectorized dot operator. This is also referred to as like operator broadcasting in Julia. What this means is that all the binary operations like plus, minus, exponential, or whatever, you have a corresponding operation defined called dot plus, dot minus, and dot exponential, which performs an element-wise operation on arrays and matrices similar to how you do that on numbers. So if I have a vector, this is just 1 to 5, so range. So just think 1, 2, 3, 4, 5. I want to square it. I can use the dot operator to square all of them. This is good because this is very fast. This is as fast as vectorized Python or MATLAB. And this does not create a separate memory in the computer for intermediate objects. It directly like affects the output. And you can do like very intuitive but good operations. So if my vector 2 is just 1, 4, 9, 16, 25, I want to find which of them are greater than 10. I just do dot greater than 10 because this is also a binary operator. So it'll give me false, 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 true, true. Now, if I want a specific subset of that, I can just do vector 2 of the indices which are greater than 10. So it will not give me anything for false, only give me for true. So I have this specific subset of vector. Tuples. I don't use tuples much because I think in like numerical mathematics, there's very less incentive to use it, but I think it's very useful. And this is just a collection of variables of different types. You can create it using the round bracket, and you can access it just using like how you would access an array. And you can also have named tuples, so you can have first name, last name, ID, whatever. And you can access it similar to how you access object. So tuple dot the name that you have. This is an example. And these are also immutable, which means that you cannot change it once it is created. So these would be very useful if you want to store like information for users or something that you do not want to be changed later, like birth date or something. So tuples are useful there. Then you have sets. Sets is very nice, and like it is an efficient implementation. The difference between sets and arrays would be that sets are not ordered. And the second difference would be that all elements in the sets have to be unique. I find sets like occasionally very useful. For example, if you, let's go through the example first. I created two sets, set one and set two. You can just create using the set function and square brackets. So look at these elements of set one. It is 1, 2, 2, 3, 4, 5. But sets cannot contain repeated elements and they're not ordered. So if you actually look at, even though I created it like 1, 2, 2, 3, 4, 5, if you look at it, it's just 1, 2, 3, 4, 5, not ordered. And you can perform nice set operations like union, intersection, symmetric difference, or whatnot. And these are very useful. For example, if you have 10,000 files, some of them are duplicates. And if you have two folders, you want to find the common file between them. You don't need to like run a remove duplicate operation. You can just create a set of the file names, do an intersection, and copy those files in a new location or something like that. Sets are also very useful in like, if you have like geospatial operations, if you have latitude, longitude, and something related to that, and you have some repeat or duplicate information, or if you want to find overlap between cities or whatever, sets are very useful there. Next, we have the dictionary type. This is very similar to dictionary in Python or other languages. You have a key value pair. This looks very similar to tuples. They are slightly different. Like in dictionary, the order is not important. You just have pairings of keys and values. And tuples are cheaper to construct because you cannot change them later. So we have looked at some functions before, but now we are going to formally talk about functions. The syntax is very simple, conventional. You have function keyword, name of your function, input arguments. You can do operations and have a return value. You can also have break statements and other things in order to like, if you're doing a loop or something within a function. Julia also has another syntax for function, which is more like a functional language or a mathematical syntax. So you can define a new function called f of x equal to return value like x square or something. And this will work as it is. So functions, we talked about types, and I just want to go through like one of them again. Like I create a function called add1, and this takes an input n and it returns the next number. I can also create it like using mathematical symbols. And by convention, usually what people do is if you have just one line functions, you can use this syntax. But if you have more than one line function, try not to like fit everything in one line and just to use the syntax. Like it's better to have a function with multiple lines. It's easier to debug. But if I have a function add1 and I'm returning n dot plus 1. So this works for both one number and for array. So if I add 1 to an array like a random between 0 and 1, it will add all of them. But if I just return n plus 1, it will give me an error for array. You cannot add to an array without using the dot operator. So keep that in mind. And you can make any mathematical function more ubiquitous by using the dot operators, or depending on like what types you want. So Julia has one more very interesting feature, which is the exclamation notation. So what this is that these are functions, and the difference is that you just add an exclamation mark after the function. And when you use it, these functions can modify the input in place. The advantage of this is that you're not creating temporary variables to store the output, and it is faster on memory. So I have another function, add one. You can have multiple functions with same name but different types, as in other languages. It's called like function overloading. But I create like a function called add one exclamation mark. This is returning some adding one to the input and returning. So let us look at two variables, 5, 6, 7, and 1, 2, 3. If I use the older function without the exclamation mark, you still have to define it. I defined it previously, so I'm not defining it again. This one. So if you use the older function, you add one to 5, 6, 7, you'll get 6, 7, 8, but the original variable remains as it is. If you use this exclamation mark, it modifies the original variable. So where 2 was 1, 2, 3 here, I added 1, it became 2, 3, 4, but the original variable is changed now to 2, 3, 4. So this is much similar to like if you know about pointers and references in C++. Yes, Camilo.
If you send a chart, a string as parameter.
So in this function, it will give me an error because this operation is not defined for char. But if you have like x comma y and you do x plus y, for char or strings, it will just concatenate. So it will, so in the base Julia, you have defined the same operator like plus, a different definition for string, different definition for integer, for float, and complex numbers and whatnot. The compiler can choose. Right. So this is like one of the last slides I want to talk about plots, because everyone likes to look at plots. Plotting is very easy in Julia, very similar to Python. It has a library called plots.jl. And I just created a very basic random numbers of hundreds, squared it, and plotted it. The interesting thing here is that plots provides a bunch of what is called backends. So you can use different backends with the same syntax to create a publication quality like LaTeX style figure, or if you like our shiny style figures, you can use that backend and whatnot. So I do not have too many examples here, but just two examples, one for the default backend, which is called GR, and another for the Python plot backend. So if you like Python and plotting, you can use similar syntax to Python as well. It's pretty similar. And ignore the compiler warnings here. So I think that's pretty much it. I wanted to give you one example. Finally, like Julia has a very good ecosystem for numerical methods and solutions. So I would say if you want to do anything with like mathematics, simulation, or statistics, Julia has a good documentation, and the language was written to be intuitive. So if you are a mathematician or something, you don't need to like learn a whole lot of coding to do that. And this is straight away an example from the documentation, very easy. It's called Lorentz equation. This is the basis of all climate models today. And this is basically what's called a deterministic chaos equation. Like for some specific parameters you choose, you can get output which is deterministic but not repeatable ever. And to solve this, you can create a Lorentz function. Look at this exclamation mark I'm creating, which means that it can modify things in place. So you don't need to create temporary variables later. But if you know these equations, it's very straightforward to just write it in Julia. So U is displacement, U1 is like XYZ, and then you have sigma Y, whatever. So this is like in 3 dimensions, like XYZ. You have a couple of parameters, what we call P here, and then a couple of constants. For specific initial conditions and for these constants, you get very interesting graphs. So what we do is that we create a differential equation with 3 different partial differential equations. We create a function with 3 different partial differential equations. We can specify the initial conditions and parameters, and using the differential equation library, specify like the start and the end time, and just solve it using an ordinary differential equation. So you can get this nice Lorentz equation, strange attractor plot. One more interesting thing, this is not like intro, so I did not talk about this. What I like about Julia is that we talked about types and having custom operators. Suppose you look at the like backend of the ODE problem and it is doing some calculations. You want to create a custom multiplication operator, which is like specific to your. So if you have like two matrices and you want to do some specific calculations, you can define the multiplication operator to do your specific calculations and pass them in this ODE problem functions. It will work as it is, just with like a tiny definition. So just want to end with that, like with 5 lines of code, you can solve a big partial differential equation, and you have a lot of documentation for this. And finally, the disadvantages of Julia, or just like to be fair, one of the disadvantages is that Julia, not being a compiled language, if you create a product and you want the other person to use a product, they also need to have Julia and need to be able to use Julia. So there are like tricks to create a binary executable, but I think that is one gap or one reason for why Julia is adopted in academia, but not so much in the industry, or where people who don't care about code only care about output, like do that. So I think that is it. I can take questions. And yeah. We have one question. I know this is out of the scope of intended, but are you aware of MLDL libraries? I am aware of machine learning and deep learning libraries, but I haven't used them in Julia, so I cannot endorse them yet. But you should check out flux.jl. I think that is the most prominent library, which is very equivalent to scikit, keras, and even some properties from TensorFlow or PyTorch. I do not. I know there are deep learning libraries, but I do not know if there are fully equivalent libraries to like PyTorch or not. But I think flux.jl is a good starting point. Yeah, Paul.
I know that for a while there was some efforts, and I think you alluded to this, to create like statically compiled Julia binaries. Do you know how, like, I think package compiler was a Julia package. Do you
Yeah.
know how that's progressed? Like, is there still like an active effort there?
So I do not know that. I did like look into that when it was like a little more popular, but given that I do not know and I haven't found them, maybe it is not like gaining traction. But yeah, I can't answer that. It would be good to have. I think a lot of people are trying to like look at Mojo these days for Python for the same thing rather than Julia. So we'll see. Okay. Right. Thank you for coming, everyone.